Hi all, welcome to my channel again, and this is another video on graph, and here we will discuss about what is spanning tree and what is minimum spanning tree. So before going to spanning tree and minimum spanning tree, two terms we have to know, that is undirected graph and connected graph. So this I have explained earlier also. So to find a spanning tree or minimum spanning tree of a graph, the graph should be a undirected graph and a connected graph. So to do a recap kind of thing, so what is undirected graph? So here if you see, I have taken one example of a graph where directions are present, means from 0 to 3 there is a direction is present, and from 0 to 1 one direction is present. But a undirected graph means there should not be any directions, meaning from 0 to 3 and 3 to 0 bidirectional connection should be there, means no direction should be present, then only it is known as undirected graph. Now what is connected graph? Connected graph means where there always should be one path from any node to any node. From any node or any vertex to another vertex, always there should be a connections. Suppose I want to go from 1 to 3, there should be always a path like this, and then this maybe from here from 2 to 0, then 0 to 3. A graph will be known as a disconnected graph if there is no connection between that node to another node. Suppose if 4 is present here, in that case this 4 has no connection with other nodes, okay, or maybe from 1 I can't go to 4. So this is actually a disconnected graph. So to find spanning tree or minimum spanning tree, the graph should be always a undirected graph and a connected graph. Then only we can find the spanning tree or minimum spanning tree of a graph. Next, we have to know what is a spanning tree. The definition says a spanning tree is a subgraph of an undirected connected graph, which I explained earlier, which includes all the vertices of the graph and where the number of edges will be minimum. If a vertex is missed or not connected, then it is not a spanning tree. So let's take one example. So this is my original graph and this is one undirected connected graph, if you see. So the definition says I have to find another subgraph where the edges will be present, but minimum number of edges will be present to make it connected. Okay, so one possible spanning tree of this original graph will be this one, where I have removed this edge, and still if you see, each and every node or vertex is connected. Okay, another possibility is maybe we can keep this edge but we can delete this one. So if you see here, this is also one example of a spanning tree where by using minimum edges we can connect each and every node, and that is derived from the original graph. So another spanning tree will be possible if we delete this edge, then these three can make one another kind of spanning tree. So this is all about spanning tree. So one more theory to know here is, if a complete graph is consist of n vertices, then the total number of spanning tree possible is n to the power n minus 2. So what is complete graph? If you remember from the first video, the complete graph means where each and every node is connected via one edge. Means from 1 to 2 there is a connection, 1 to 3, then 1 to 0. From 0 also 3 to 1, and from 2 also 1 is connected, 0 is connected, and 3 is connected. So in a graph where each and every node is connected via one edge, that is known as a complete graph. So for a complete graph, the number of total number of spanning tree which we can build is n to the power n minus 2. So we will come to several other formulas also later point of time. Okay. So now what is minimum spanning tree? So in the previous section we learned what is a spanning tree, but what is minimum spanning tree? So the definition says a minimum spanning tree is a spanning tree in which the total weight of the edges is as minimum as possible. That means this minimum spanning tree is applicable for weighted graph. Weighted graph means where there will be one weight assigned between the edges. So from A to B or B to A, the edge is 4. Sorry, the weight is 4. So like that way, we have to find one spanning tree where if we do a total weight of the edges, that should be minimum. So here in this case, in this example, if you see, if I take this edge 4, then 2, then 1, then I can connect all these nodes, and that will be my spanning tree with minimum weight of the total of the edges weight actually will be minimum. So other than that, if we take anything else, the weight should be or will be more. So if I take this root and this root, then total will be 4 plus 2 plus 1, that is 7. So that is my minimum weight to connect all these nodes. So if I take this one, then this one and this one, then it will be 4 plus 3 plus 1. That will be 8, that is more than 7. So this is all about minimum spanning tree. So now how to find this minimum spanning tree and all, that we will explain. So to find the minimum spanning tree from a graph, we can take help of two useful algorithms. One is Prim's algorithm, another one is Kruskal's algorithm. So how to find this minimum spanning tree using Prim's algorithm or Kruskal's algorithm, that we will make separate individual videos, okay, in next section. Now we will discuss about few applications which we can make use of spanning tree to solve those things. So the spanning tree applications are like computer network routing protocol, okay, then cluster analysis, network planning, and minimum spanning tree applications are for like pathfinder, in a map, and telecommunication networks, water supply networks, and electrical grids. So for this purpose also we will solve few problems in next videos, then to make it clearer how spanning tree is used, that we can see from there. So about Prim's algorithm and Kruskal's algorithm, I will make separate videos in next lectures. Thanks for watching this video. This video is till here only.